All right, what's up, guys? In this video, we're going to pick up some more calculus here, and we're going to do another example of finding the radius and interval of convergence for a given power series. So we're given this series here, and we want to find the radius and interval of convergence. So what you do is you basically use the ratio test, and let me just remind you of what that is very quickly. For the ratio test, it basically says that L is going to be equal to the limit as, I'll just use K since we're using K, as K goes to infinity. It's going to be the absolute value of a sub K plus 1, all divided by a sub K. Now we know that if L is less than 1, it converges absolutely. I'll just put ABS for absolutely. If L happens to be greater than 1, or let's say we get infinity, then it diverges. Well, in our particular case, if we end up getting infinity, the radius of convergence would be 0. And then if the limit is equal to 1, then it's inconclusive. So that's just the ratio test. If you don't know how to do the ratio test, or you're not familiar with what that is, I have videos on that too. Okay, it's one of the most important convergence tests that you'll be using in Calc 2, so you'll certainly want to be make sure you know how to deal with it. So let's go ahead and do that. So we got the limit as K goes to infinity, and so we go ahead and substitute everything in, and I'll do all of the simplification and whatnot for you to see it. So we'll have x raised to the k plus 1 all divided by k plus 1 factorial. We'll divide all of that by x raised to the k all divided by k factorial. Now remember that dividing by our a sub k in this case would be the same thing as multiplying by the reciprocal of it. So we can actually write this as the limit as k goes to infinity, and it'd be the absolute value of x raised to the k plus 1 all divided by k plus 1. Now we'll multiply by the reciprocal of the denominator, or the reciprocal of our a sub k, which is just going to be k factorial all over x raised to the k. So hopefully you're with me on that so far. Now we'll need to simplify this since this is the limit as k goes to infinity. Once I do the simplification, I can pull out the absolute value of x. Now when you pull out the absolute, or when you pull out the x, you have to leave it in absolute value. Do not take it out of absolute value. You need to leave it out. You can pull it out, but leave it in absolute value. And then we'll have the limit as k goes to infinity. And I can drop the absolute value bars, and if I do simplification, I'll have 1 over k plus 1. We'll take the limit there. Okay, so this gives me the absolute value of x. We got our limit as k goes to infinity. And notice that if we take the limit here, we're simply just going to get 1 over infinity, which is 1 over any large number is going to get closer to 0. So we'll just end up getting 0. So we'll have the absolute value of x multiplied by 0, which is obviously 0. And so L here, our limit, is 0. So that means that the power series here will converge for all x. So it converges for all x in this case. So with that being said, we know what the radius of convergence is, and we also know what the interval of convergence is going to be. So remember, if we since we end up getting 0 as our limit, then the radius of convergence, which I'll just denote r here, is just going to be infinity. So the radius of convergence here is just infinity. The interval of convergence in this case So our interval of convergence, which I'll just denote I, that's just going to be negative infinity less than x, which is less than infinity. And that would essentially be our radius of convergence and our interval of convergence. Okay. And that's pretty much how you do it. Okay, so again, this isn't the only example that I have, so you're more than welcome to take a look at other examples, but that's going to be your answer. I'll see y'all next time.